cars have sensors, radars, camera, which generate huge amount of data. So transferring this huge amount of data to the cloud may create congestion on the 5G network, and so will take advantage of being offloaded to the Wi-Fi network.
Hey, this is Martha DeGrasse here again for the Wi-Fi Alliance. And this is The Signal, our podcast, where we bring you insight and perspective from leaders from across the Wi-Fi ecosystem. If this is your first time joining us, thank you so much for being here. And if you're familiar with our podcast already, please take a minute to rate and review on your favorite podcast app. In this episode, we'll be learning about Wi-Fi 7 in automotive with Franz Dugand. He is Senior Director of Product Marketing for the Wireless IoT Business Unit at ceva. Franz, thank you so much for being here today.
Hi, Martha. Nice to be with you. Very excited to have the opportunity to discuss Wi-Fi.
Yeah, so are we. Start off, if you could, by telling us a little bit about ceva and your role there.
Yeah, thanks for asking. Ceva is not a widely known company. However, we have been around for, I think, more than 3 decades. And actually, there is a very high chance that you are using a product that contains a ceva technology. We actually recently announced and celebrated the 20 billionth ceva-powered device. So in a nutshell, ceva develop silicon and software IP solutions for the consumer electronics, IoT, mobile device, PC, infrastructure, industrial, and of course for automotive as well. So our solutions include neural processors, from low-power edge AI to more advanced generative AI. We also offer DSPs for communication, vision, and audio. We also have sensing and audio software offering, including codecs, voice processing, spatial audio, sensor fusion, and more. We have cellular technology, so providing 5G and beyond for handset, IoT, and base station as well. And last but not least, we also have a wireless connectivity offering, so comprising Bluetooth, Wi-Fi, and ultra-wideband. So my role is a product marketing director for wireless connectivity. So I define the product lines and the roadmap and make sure our partners develop optimized and differentiated products that tackle the challenges of their target applications.
Okay, excellent. And tell us a little bit more specifically about how you play in the automotive sector.
Yeah, excellent question. Particularly in the automotive, so the technology we develop actually are somehow agnostic to the target segment. So we can address most of the market segments, so the one I was just listing before, and for sure for the automotive as well. So we have numerous customers actually playing in the automotive space. Talking about my particular domain, so which is connectivity. So we have customers using our Bluetooth and Wi-Fi and also ultra-wideband in automotive applications.
And how is Wi-Fi 7 enhancing those applications?
Yeah, that's an interesting question, actually. So Wi-Fi 7 is a quite recent generation, but is penetrating the market very fast. The additional features that it brings provide significant benefits for many applications, including automotive for sure. First, Wi-Fi 7 is faster, so faster than the Wi-Fi 6. It is also referred to extremely high throughput in the Wi-Fi standard. So compared to Wi-Fi 6, for instance, Wi-Fi 7 is up to 4.8 times faster, thanks to various improvements with a twice larger bandwidth, twice higher MIMO capability, and higher level of modulation. So basically carrying more bits of information per symbol, which is sent over the air. So you can do faster firmware update over the air, faster data transfer in general, which is getting critical in connected vehicles as the embedded cameras and radar generate a huge amount of data to be transferred and processed on the cloud. But there is more than that. So it's not only faster. Wi-Fi 7 also comes with better spectrum utilization and deterministic low latency. So that's certainly the most important thing of Wi-Fi 7. There is a feature that is called multi-link operation that enables a device to simultaneously listen to 2 different channels or more. So this is very interesting capability, particularly in dense area or noisy environment. To explain, let's have a closer look at maybe an access point. So a Wi-Fi access point can operate on various bands, so 2.4, 5, and 6 gigahertz bands. So to cope with the network capability and noise, interference, and load balancing, a Wi-Fi access point may decide to schedule traffic over the air on any of these three bands, 2.4, 5, and 6 gigahertz. But a Wi-Fi device, which is connected to the access point, does not know in advance on which band it will receive the packet from the access point. So that was before Wi-Fi 7, actually. Before Wi-Fi 7, this device had to listen on one channel, for instance, on the 2.4 gigahertz band, then switch to another channel, listen again, etc. So it may waste a significant amount of time by switching from one band to another, so which is not good for latency-sensitive applications, and particularly in automotive, for instance, car-to-car communication or safety applications, other safety applications. Since Wi-Fi 7, actually the device can simultaneously listen to two or more channels on different bands, so simultaneously, so which means that it cannot miss a packet sent by the access point, so which provide what we call deterministic low latency, so which is key for timing critical application like safety.
Okay, great. Let's talk a little bit more about the use cases, both for driverless cars and cars that we drive. You mentioned safety. So driver assistance systems, I think, is an area where Wi-Fi is really able to make a difference with these low latency capabilities, right?
Yeah, that's correct. Actually, talking about, let's say, all the use cases we can find in automotive, there are many actually. The first application we have seen is infotainment that I think everybody knows with Android Auto and Apple CarPlay. The first generation were wired, so you had to physically connect your smartphone through USB to your car to enjoy your mobile applications on the car screen. So now you can do it wirelessly thanks to Wi-Fi. Wi-Fi is also used for firmware update. Actually, there is a trend for software-defined vehicles that have large software to maintain and update. So the firmware update over the air is becoming a must-have to fix bugs, improve the performance of the vehicle, and even add new features. Now talking about safety, like car-to-car communication, so which is also called V2X, so vehicle-to-vehicle and vehicle-to-road sign or infrastructure. Car has many things. There are onboard cameras, radar, which generate huge amount of data to be transferred and processed on the cloud. So offloading data from cellular to Wi-Fi offer a faster and more cost-effective solution actually for those connected vehicles. So that's one of the advantage of using Wi-Fi for this kind of application. On top of that, generally speaking, there is a trend to go wireless to replace wires, simply said. As you know, there are kilometers of wires in a car. Removing as many wires as possible will help to reduce the weight, hence to extend the range of the car and reduce maintenance costs also because the connectors may fail over the time. Things like cameras, radar, and even ambient lighting and other sensors may go wireless in the future. Even battery management system, so which has tons of wires to interconnect all the battery cells, they could benefit from Wi-Fi. So there are other wireless technologies to address that, but Wi-Fi also has some key advantages there because it provides the right throughput, the right range and reliability and latency, and it's cost-effective solution. So for actually all these applications.
Great. So how exactly is Wi-Fi 7 used for vehicle-to-vehicle communication? The vehicles are not using Wi-Fi to talk to one another, or they are? Are they using Wi-Fi to offload the data that they generate when they communicate with one another?
Yes, that's interesting. There are actually two major technologies addressing the V2X. So one is based on cellular, which is also called the CV2X, or cellular V2X, which is based on LTE and now 5G. And the other one is called DSRC, which stands for Dedicated Short Range Communication, is actually, this is based on IEEE specifications, so 802.11p and 11BD, which are actually a derivative of technology used in Wi-Fi. So those two technologies, Wi-Fi and 5G, are somehow competing each other for the V2X. And also for firmware update, because both, actually, any of the two can be used for just firmware update. So they are somehow competing because they address the same use cases. However, actually, the two are deployed on the market. So depending on the region, so I think US is using a cellular technology. Europe is more around DSRC, so the Wi-Fi based technology. Anyway, they are competing each other, but actually they have both their own strengths and weaknesses. So this is why I think in the future we will still see them coexisting. Wi-Fi offers better performance, particularly in dense and dynamic environment, while 5G is more optimized for long-range communication. And also, so as I mentioned earlier, cars have sensors, radars, camera, which generate huge amount of data. So transferring this huge amount of data to the cloud may create congestion on the 5G network, and so would take advantage of being offloaded to the Wi-Fi network, actually.
This is offload that's going on in real time as the cars are driving around, not like waiting till the car is done for the day and then it uploads data to the cloud for analytics. This is real-time offload, right?
Good question, actually. Yes, both can happen, exactly. I'm not personally into the details of how, I would say, the solution provider for car-to-car communication are addressing that. So there are solutions which actually support both. We have customers, actually, who have solutions, so chips and software that support both cellular V2X and the DSRC. So indeed, which means that both need to be supported, either one or the other, depending on the use case, or indeed dynamically, so switching from one to the other for the data offload.
Okay, that makes a lot of sense. And I'm guessing that all this data will grow exponentially as connected vehicles use more AI. Can you give us a little bit of an update on AI use cases that relate to connected vehicles?
Yeah, interesting. Yes, AI is everywhere, particularly in vehicle. Can be used to improve, basically to improve the Wi-Fi performance. Actually, just the Wi-Fi communication by itself. AI can be used to improve the link quality, to better allocate network resources to each device which is connected. But AI is also widely used at application level. So, as you know, the vehicles are embedding many sensors, radars, and cameras, which are generating huge amount of data. And so AI is used to perform local processing and take decisions. So it's particularly important in ADAS, autonomous driving, etc. But there is another aspect which I didn't talk about, which is actually the Wi-Fi sensing. So that's interesting to know that actually Wi-Fi can be used to sense the environment. So today, I think, and particularly in automotive, the most popular technology used for sensing are millimeter waves radar and ultra-wideband. There is an alternative, which is Wi-Fi sensing. So it's relatively new, but quite promising. Actually, the Wi-Fi sensing may be a cheaper alternative. It provides close performance to ultra-wideband and can be a great alternative, for instance, for applications like child presence detection. Child presence detection can be used to trigger an alarm. So when you forget your baby, so believe it or not, but it happens. So it's a key requirement from various automotive organisms like Euro NCAP, etc. Today, this is addressed with mostly millimeter wave and ultra-wideband, but many people now are talking about and are working on this topic and trying to tackle the same challenge, but using Wi-Fi, which can be a quite great alternative. So it can be used for child presence detection. So as I mentioned, to trigger an alarm when you forget your baby. It can also be used to automatically enable or disable the airbag. So when the baby is detected on the front passenger seat. So that's another use case, actually. Wi-Fi sensing is great application and for sure take a lot of benefit from AI. So all the algorithms or for the sensing by itself. So actually you collect some interesting data from the Wi-Fi channels or from the Wi-Fi network. And then with an AI-based algorithm, you can process those data and address those particular use case I just talked about.
Excellent. All right. Is there anything else on the horizon for Wi-Fi 7 that you want to be sure and update us on while you're here?
So there is a continuous improvement of the standard. So Wi-Fi 7 is on the market. Now people are actively working on the next generation, Wi-Fi 8, which will provide even better performance. It's a high efficiency technology. So the next generation will provide even better latency, better efficiency, higher throughput, etc. It's considered to be wired-like technology. So that's the idea behind Wi-Fi 8. So it's really interesting to note that, the focus is on reliability, not necessarily to increase significantly the throughput, but it's all about reliability, low latency, etc. So to have something which is equivalent to a wire. So for sure, the automotive will take a major benefit of that. Yes, that's what we see actually. So the car-to-car communication and car-to-infrastructure communication will take a lot of benefit of this next generation. With Wi-Fi 7 and derivative, you can address those use cases already pretty well, but the future generation will provide better improvement, particularly in dense area, in cities. There will be a communication between access points so that you can do a handover seamlessly and faster in order to not lose packets and have a seamless communication, which can be critical, particularly for safety applications to detect obstacles and cars in blind spots, etc.
Excellent. All right. Franz Dugand, Senior Director of Product Marketing for the Wireless IoT Business Unit at Ceva. Thank you so much for being here today. This has been really great.
Thanks, Martha. It was really a pleasure.
It was. And that is our show. Again, please take a minute to rate and review on your favorite podcast app. Thank you so much for joining us on The Signal. We hope you can join us again next time. Thank you.